Hello everyone. So welcome back to Dilip IT Academy and my name is Dilip Singh. Yes, as part of our microservices sessions, today we are seeing Spring Cloud Config Server. So what is a Spring Cloud Config Server? And continuation to that, we have concept called as config clients also. So that means we have to understand config server and config clients as part of our microservices applications development point of view. Yes. So generally, whenever we are working with microservices, assume you are having 30 to 40 microservices in your application, then every microservice is required DB credentials, for example. Then what we are going to do? We are going to provide DB URL, username, password, all this information individually at every microservice application.properties file level, right? So what is the point? What is the drawback here? We are adding the same data, repeated data every time in each and every microservice level. Okay, so tomorrow if there is a change in the credentials or is there any change in the URL, hostname or whatever it is, you have to update same information in every microservice again and again. So that means the maintenance of the configuration data becoming very critical in this scenario, right? So it's not a good solution. So in such case, if we are making same data in a centralized place, in a common place, and we are connecting that centralized configuration area to our microservices, and all our microservices are going to get configuration data dynamically every time from that centralized location. That is the agenda of Spring Cloud Config Server. So that means we are going to make sure the configuration in a centralized location which is commonly accessible by each and every microservice. So that what is the advantage we are going to get here? So if the same database credentials I taken as an example, I configured in one place along with config server. And now all my microservices are going to connect to config server whenever I started, and those are all going to get that data dynamically, and those microservices are going to scale up by using that config data. So if tomorrow if there is a change in the DB credentials as we taken previously as an example, so I'm going to make change in only one area in a centralized configuration area, and automatically the same change will be reflected to each and every microservice level. So that means the main agenda in this case is all about externalizing the configuration data as well as centralizing the configuration data with respect to all microservices accessibility. So here we are going to deal with specific to microservices as well as common to all microservices. Two types of configuration data we are going to have, and we are going to deal these two types of configuration data as part of our Spring Cloud Config Server. And after that, continuation to that, we are going to have one more session, Spring Cloud Config Clients. So in this session, primarily we are focusing more and more on the Spring Cloud Config Server, and this is a powerful tool which is centralizing all microservices configuration dynamically. In this session right now we are exploring how Spring Cloud Config Server we have to implement and how it is working with a hands-on session. Let's start looking into session right away, and please like, share and subscribe my channel for further more updates and as well as content. When it comes to the Spring Cloud Config Server and config clients, let's take the architecture of once Spring Cloud microservices. The moment you take in microservices, if you observe this architecture diagram, so in this case, if you observe here, we are done with this service registry and we are done with gateway, right? Now, here we have one more component called as config server concept. So this is what we are discussing right now, config server. And what about the config clients? So these are all microservices again, we are going to make as a config clients. So that means similarly, we did same thing, right? I mean, purpose is different, 100% is different purpose with respect to config server and service registry point of view. But on an ideology point of view, service registry is a separate application and all our microservices acting as a Eureka clients or discovery clients. Similarly, config server is a different application and all our microservices again are going to act as a config clients. So that means again to create config clients, again we are going to use our existing microservices only. But to create the config server, we have to create a separate web application. So that is the just like overall agenda with respect to what we are going to do in between config server and config client point of view. But what is the point of config server and what is the point of config clients? Let's see here. Okay, so Spring Cloud, let me give some points and then we will understand how config server is helping us in our day-to-day microservices application development, we will try to understand. And I said, right, 99% is the most important topic. This is also. Yeah, Spring Cloud Config Server and config clients are the components which are providing an external configuration management in a distributed application system. In a distributed applications is nothing but microservices only. So that means simply in microservices applications level. So what is the point I'm trying to say is by using cloud config server and config clients, okay, so we are going to externalize the configuration management. So what is the meaning of externalizing the configuration? So this is the point, key point we have to understand right now. So externalizing the configuration management. So that means what is the meaning of externalizing the configuration management? So that means what are the challenges we already have in our existing microservices application? Let's try to understand in this case. Okay. So if you observe our microservices so far, what we did, guys, yeah, let's see here. We created almost 3 microservices as an example point of view, right? Okay, fine. So, but in real time point of view, you may have 30, 40, 50, 60, 70 microservices also, right? So that means in this microservices application point of view, right now we created user, order as well as payment point of view, but maybe you may have a lot of other things like delivery, notifications, emails. Okay, so a lot of other microservices you may have it, like around 40, 50 microservices you may have it. So these are all microservices. Okay, so we created like user service as an example point of view, and we created like order service, and then we created like a payment service. Okay, so we created in our workspace these 3, but assume like you have a lot of microservices. Okay, so just let's take it as a figure like 40, 50 microservices, whatever it is. So now the biggest challenge across all these microservices implementation, whenever we are implementing all these microservices, what is the biggest challenge? For example, if you go to user microservice, let me open the properties file. So why I opened properties file? If you understand the point again, configuration. So that means in Spring Boot applications, we are always doing configuration in the properties file level or YAML file format. Both are same, whether it is a YAML or application.properties file, properties or YAML file, whatever it is. But simply we are making all our configuration. Configuration means what? Username, passwords, DB URLs, okay, context path, port numbers. This is all comes under the configuration. You're configuring your Spring Boot application with respect to database point of view, context point of view, port numbers point of view. All this information you configured here. We configured in this microservice. Okay, cool. So for example, if you taken in this case, 3 microservices are always using the database. That's why what I did, the moment I taken JPA module, everywhere I have to add the DB properties. So 3 microservices, in 3 microservices you added the database. So tomorrow in 40 microservices, okay, for example, we taken what? The best example point of view, DB properties. So in this case, what we did, we added DB properties in 3 microservices. So tomorrow, same thing, you have to repeat same configuration data, same properties added in all 40 microservices. So what is the meaning of added in all 40 microservices? That means same information once again, if you go here, this is the information, repeated information you are maintaining into all microservices. You are maintaining same data into all 40 microservices. Okay, fine. Maybe for the first time you did that. Assume I got a point like DB password changed. Some reason I changed my DB password from C ## Dilip to, okay, see existing password is Dilip. So that I change it to something like, some reason I change it to XYZ123. So why? The reason, whatever it is, I changed it. Now, the moment your password got changed to XYZ123, what will happen? All 40 microservices, assume all 40 microservices applications started deployed and working as expected. But today, all of a sudden, the password got changed. Then what will happen? all 40 microservices will fail. Why? Because the reason is password got changed so that you will get invalid credentials error while you are making the database connection. So then to resolve this error, what you have to do? You will start, what is the change we will do? We will start making password change in every microservice. So that means how many places you have to make the change? 40 places. You have to make the change for in 40 places. You have to identify wherever database password is used, not only 40 places. Anywhere else your database password is there in entire 40 microservices point of view, you have to identify and you have to do change everywhere. For example, we taken 40 times. So you have to make change in the 40 places. So that means what's happening, guys, in this case? Maintenance of microservices becoming difficult. Why? You made same change in the 40 places. Okay, fine. It is only for database point of view. That's okay. Now I'll take one more scenario. This is use case one, the regular use case. That's why I taken this first one. Now second case I will take. If you go to again, assume this URL I will talk about. So we know what is the service register URL and we made all our 40 microservices as Eureka clients and everything. So now in every microservice also this property is important. We know that this property is most important property in every 40 microservices. Some reason, even this URL, maybe I changed context path, whatever the reason it is, some reason the URL got changed like this. That means the context path of service registry application, I changed something like, someone suggested me like, don't keep the registry, just keep no context path like that. So then this is the new URL now. So that means what happening now? This is the new URL. This is the old one and it is working okay. But all of a sudden today, some reason in the service registry application, you remove the context path. Some reason. Okay. Some requirement point of view. So then what's happening? This is what became your new URL. Fine. Now what you have to do again? You have to do change in the 40 microservices. Again, you have to go to 40 microservices and you have to make the same change. So you have to make same change again in the 40 microservices. So that means 40 places again you are doing in the same thing. Not only 40, wherever you are using this URL, old URL. So everywhere you have to replace with new URL value. See, key is same. I'm just talking about value point of view. So that means again 40 places you are doing the change. So that means in this case also maintenance of your microservices is becoming difficult, especially the configuration data got changed. Especially configuration data got changed. So these are the challenges we are getting across microservices applications, because sometimes we may miss one of the microservice, in couple of places we forgot to change DB password. So then also you will see application failures. And even though you changed everywhere, but unless you are spending a lot of time and you are changing in 40 places, here also 40 places like that. Okay, this is one more use case. Now one more use case I'll take. Assume in our Spring Boot framework level, we discussed already. Whenever I want to add an external user defined, okay, whenever we want to add an user defined property, we can add, right? We can add and we will take that via, we can take something like contact.email equal to info@dilipit.com, something like that. We taken our these things also, how to add user defined properties and how to access these things into our Spring Boot application. So we will use an annotation called as @value annotation in our component classes, right? And there we will define all our microservice ID, like write this, right? I'm not writing everything okay. So contact dot email ID, something like that. We will take a value annotation and we will define that respective user defined property, and simply like we are making field injection. So we made this. So this property we defined where, guys? Again, this is the property you added in the application.properties. So this is the property you added again in the properties file. Okay, cool. Now my point again, here it is. Okay, this is added in the properties file, application.properties file or something in one of the micro. Now the point here it is, same property name and same email ID I want to use in assume some reason 40 microservices. 40 microservices. I want same email ID. I want same email ID everywhere. In 40 microservices, some reason everywhere I want this email ID. Some reason, whatever it is. All 40 microservices level, I want this use mail ID. Then what you will do? So again, in 40 microservices, we have to add same property. In 40 microservices, like for example, if you go to the user microservice application.properties, and here what I am doing is, so what I am doing here it is, I am writing contact.email equal to, so something like info@delipit.com. Something I added this. Now same URL, sorry, same property, how many places you are adding? User microservice, payment microservice, order microservice, and etc. 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 You are adding into 40 microservices. Why? Some reason you are using this email ID in your controller classes or service layer level, wherever it is, some reason you are using this email ID everywhere. So that means some common values across microservices. The use case here it is common, okay, configuration data across multiple microservices, across many services, many microservices. It might be more than 10, 15 like that. Not only all, maybe more than 10, 15. So it's all about common point of view. This is the use case we are discussing. So again, what you are doing, 40 microservices, you are adding the same property. Okay, cool. So you added in 40 places. That is also one of the biggest effort you are spending. 40 microservices level, you added copy paste. Now, some reason after 6 months or 1 year, someone said like, no, we don't use info@gmail.com. It is not looking good. So let's make contact@mail ID itself. So contact@delipit.com. So that means what is the point here? It is maybe it is changed something or someone else. Okay, this is how the email got changed. Then what you have to do again? Again in 40 microservices, what you have to do, guys? You have to do 40 places. You have to update the same property. Update the same property. So that means what's happening here? The moment you maintain each and every property, okay, the moment you maintain properties at every microservice level individually, application maintenance, microservices maintenance becoming very difficult whenever there is a change in that respective properties. So in today's world, whenever we are working with real-time business applications, definitely data will change every time. So we can't give the guarantee like static data permanently. So in database point of view also, people will change DB passwords frequently sometimes due to security reasons. Right? Similarly, maybe email IDs will change. Similarly, some other things will change. Right? Port numbers may change, host names may change. So that means frequently data is going to change. But if you are making at every microservice level individually, so what is the challenge here you are facing? The maintenance of the application. Maintenance means supporting the application. Whenever those applications you want to make a change, for small things also you are making every time into 40 places. If I taken 40 microservices as an example point of view. So this is how the biggest challenges we are having when you are dealing with microservices, especially with configuration data. So one more use case, maybe one more use case point of view, I'll take like, okay, someone else said, I want a property, something like a company name. Assume you are working, this microservices application is for the Amazon point of view. Okay, let's take like Amazon. So this is what company name, right? So now I'm taking like company dot name equal to Amazon. So now again, this property also I want to use in many microservices. So maybe assume 30 microservices out of 40. Some reason I have this property also. That means everywhere I want Amazon value as it is. Something like Amazon private limited or whatever it is. So that means what happening again in this case also, you are adding same property into 30 microservices. So add in 30 microservices. So see here, the moment whenever you have a configuration data across all microservices, and that too if you maintain all the things at every microservice application.properties personally, okay, or individual microservice level, the challenge is you are repeating the same data again and again. So in this case, what is the drawbacks, guys? Now let's identify the drawbacks from this discussion. So what is the drawback? First of all, data redundancy. Configuration data redundancy. So what is the meaning of data redundancy? Means duplication. Redundancy means nothing but duplication. So same data again and again, again and again, again and again, again and again, you are configuring in every microservice level. That is the biggest disadvantage is data redundancy. Generally, what applications will do, real-time applications will say to us, avoid the duplication, centralize the configuration, like that, right? So the biggest drawback is duplication of the properties. Second point, maintenance of the application becoming very difficult. When there is a change in the configuration data, maintenance of the applications are becoming very difficult. So there is a change in any existing configuration data. Okay, in existing configuration data, what's happening? Okay, what's happening? Change in the existing data. It's becoming a biggest challenge, like identifying all the places, and in every microservice level you have to do the change. Third point of view is whenever you are adding a new property also, maybe that property is common to a lot of microservices, then also what you are doing, same thing, you are adding at every microservice level. You are adding same property at every microservice level and you are using it. Maybe you are using as part of application, but whenever that got changed, the value got changed again you have to do all microservices level privately. You have to go like, okay, so contact @info, okay, dilip.dilipit.com, like that. You have to do manual change at every microservice level. Okay, so now I'm doing in the order service, and then I will do again in the payment level also. The email ID change it, right? So I'm giving here again, and then again user microservice level also I'm giving like this. So that means, see, earlier the same property value I added in every microservice application.properties level, and this is also a biggest challenge. So now understand the concept of config server once again. So these are the two components which are providing externalizing the configuration. Externalizing the configuration. So what is the meaning of externalizing and centralizing? Okay, externalizing and centralizing. I can use one more word also. Externalizing and centralizing the configuration. So this is the agenda of config server and config clients. So that means now what exactly the config server concept is saying in this overall case is, from the above discussion, what it was saying is, okay, whenever you are working with microservices application, create a config server application and create a see, understand the point, and keep all your configuration data, config data, nothing but your properties, config data, keep all your config data, configure data inside this application. So for that means, now what in this case it was trying to say here is, for example, if I taken DB credentials, okay, so if I taken DB details, okay, for example, DB properties. So one of the best example is DB properties. So keep all your configuration data, which is common to all microservices or specific to microservices. Even I'll show you later specific to microservices also with respect to config server application. So first of all, concentrate on the common data across all microservices. So keep all your configuration data in a centralized or externalized application called as config server application. So how many copies you are maintaining as here? You are maintaining only one copy of information. So one time you declared it. One time you configured same data you configured where get config server application. And now what it is saying is, make all your microservices applications as client applications, config client applications, all your 40 microservices. Again, in this case, what you are doing, we are making config clients. So that means we will do small changes, like similarly what we did for a Eureka client, Eureka server point of view. So you are going to make all your 40 microservices as config clients. And whenever you made config clients, don't add. So now you no need to add these properties. Now the moment you no need to add these properties. Then, but user microservice want the DB details. User microservice want the DB details. Then how it will get? Yes. The moment you made config clients, right? What you will do the moment you made the config client, you will give the config server URL. So the config server URL. So you will add a single property called as config server URL in every microservice. So the moment you made 40 microservices as a config clients, and that means as well as you are doing what? this config server application URL, you are providing it to each microservice level. So whenever we did, what will happen right now is, so the moment we started microservice application, for example, I started user microservice. Starting means nothing but deploying whatever it is. The moment you started Spring Boot microservice, as a first step, what's the first step? What it will do is, it will make a call to config server. What it is doing is, as a first step, it will make a call to config server. That means you are already given the URL, right? So it will make a call to the config server, and this information will be loaded into your bootstrap. I mean, in the runtime memory point of view, what it is doing is, it is making a configuration call to the config server, and then automatically config server level, whatever the configuration data we configured already, right, in one place. So that data, so what will happen in this case is, so now all respective config data imported into microservices memory level. So that means what's happening this time, what it is doing is, the moment you made config clients and you added config server URL, as a first step, it is making a call to the config server. And then whatever the data you configured at config server level, all that in data got imported into your respective microservices. Now see, this DB data automatically imported at runtime level when you are starting the application. At runtime level, all this data got imported into your microservice. Now what it will do? Then it will do rest of the activities like making the DB connections and all. Like that, all 40, 50 microservices are going to achieve same functionality like this. Now, how many places you configured send data, guys? In a single place. In a single place. Now let's take the same use case again, like what we discussed first point of view. Maybe some reason DB password got changed. So what is the first point here? It is DB password is changed. So use case one is password change for one of these. So it is changed to something like ABC, something like @123 like this, 121. Now how many places you are making the change, guys? Single place. Only in one place. Where you are making change this time, the data which related to config server point of view, whatever the data you added, right? So only one place you are making, which is okay associated to the config server. So now what you are doing in this case, password you are replacing, you are removing the Dilip and you are adding the new password called as Dilip123. Sorry, that whatever it is, the new password. ABC@123, ABC@1212. So like that, you are making change in how many place, guys? One place. Whether it is 40 microservices, 20 microservices, 50 microservices, it doesn't matter for us. Simply you are making change in one place. And then again, you are restarting all your microservices. What you are doing? Simply you are restarting your microservices. But in earlier case, what is happened, guys? In earlier case, you made changes. You made same change in every microservice level personally. At individual microservice level, you made change in all 40 microservices. You know that, right? Whenever we made a code change, we have to do what? Build, again, deployment. Build and deployment. The moment you made any code change, what you have to do? You have to make a Maven build, then it will generate some jar file, and again you have to go for the deployment. So this is also a big, that means 40 times for all 40 microservices, you have to perform build operations and deployment operations, even though password got changed. Why? Because every microservice level, personally you maintain this information. But this time, what happening, guys? You are just restarting the microservice. You are not doing rebuilding why? You are not touching source code of microservices, right? In this case, we are not touching any microservice code. Any microservice code we are not touching. So that's the reason you don't need to do any builds, again generating the jar file or war files. You don't need to just restart it. The moment you restart it, what it will do? It will get the same formula again, it will apply. It will make a call to the config server and it will get the latest config data, what you configured in the config server level, and it will get it. So see how much effort you are reducing when comparing with previous approach. and when comparing with the config server approach. I can say like 95% of time we saved, 99% of time we saved. How? You made change only in one place and it is affecting all 40 microservices automatically. But here, what's happening? You made change in every microservice level personally, and you are making 40 times all each and every microservice build and deployments again and again, and you are making change in 40 places. It will take maybe 1 or 2 days extra, 1 day time. But in this case, how much time it will take? Maybe maximum half an hour or 10-15 minutes of time. So this is the biggest advantages we are going to get with the config server. This is the main agenda of config server. So now all 40 microservices you are making as a config clients. Similarly, now let's take with the use case 2 also. Yeah, this is the use case, right? Now again, so what you will do, if you go here, this is also one of the microservice, right? Yeah, this is also one of the common, generally all 40 microservices as Eureka clients. So that's why what you did, every microservice level, you added this property. Now you can remove from here, don't add here. Now same thing, again add this one also in the config server level. So how many places you added again? In one place. So that means now in your microservices level, see guys, I'm slowly deleting all the data. I'm slowly deleting all the data. So that means what? You are not maintaining configuration data, especially common data in a in your respective microservice level. You are moving, you are externalizing. See, that is what the meaning of externalizing. Externalizing and centralizing. Externalizing means what? You are making this configuration data external to microservices. It's not part of internal now. Earlier it is internal. In every microservice level, it is internal. But this time, you are externalized. You just completely avoided adding same properties into respective microservices. You externally taken one more config server application and there you added. That is what called as externalizing. And what is the meaning of centralizing again? Centralizing means yes, for all microservices point of view, you are externalized as well as in a centralized, in a common place, you are keeping all this information. Now what will happen? The same property again you added in config server level and in 40 microservices level, you don't need to add it. Why? Whenever it is trying to do the self registration with service registry application, this property is already dumped. This property is already, because why? All config data imported into microservices memory level. That is the first step it will do. So that means by the time in the runtime level, this property is already came to your microservice. This microservice, when you started user order, payment, notification, delivery, every microservice level, this property is already imported. So then what it will do by using this way URL, it will register with the service registry application. So that means in the overall agenda of config server here it is, you are externalizing and centralizing the configuration data, nothing but your properties in a central place, in a common place, instead of tightly or internally integrated with each microservice point of view. You see, this is what use case. Now, third use case. Common configuration data, same property, same use case. If I taken again, what will happen? In earlier case, you made change in the 40 microservices. But this time again, same. Okay, you've taken this property, right? What you will do? Same property, add again in the config server, add again in the config server. Yes. Now all 40 microservices you made as config clients and everywhere you given just config server URL, right? What will happen? Wherever you written @value like this, where it is picking this time information, it is getting from config server. It is getting from the config server in every microservice level. So that means you are making change in how many places, guys? Only one place. So you maintain this property in only one place, that too in the config server level. So tomorrow there is a change. So you added only in one place and it is automatically accessible by all 40 microservices. Rule number one. And tomorrow if there is a change, right now I said, right, maybe info change it to contact. Yes, how many places you are making the change? You added in only one place. First of all, the new property you added in only one place in config server. Similarly, tomorrow when there is a change in the email ID value, then change also, you are changing also in one place only, right? So you are just updated to like contact @ dilipit.com, like that you are making change in config server level. And as well as what you're doing, same thing. You're just restarting your microservices. Automatically, all 40 microservices will get latest value. On restart, restarting guys. Restarting means not rebuilding, just restarting the service. So it will, all 40 microservices, code level, new value will be injected. So new value will be injected. So this is how your config server and concept is helping us to deal with configuration data. See, it is a real time, sorry, it is a small training application we are just understanding, right? Beginner point of view. Now itself, we have like around 7 to 8 common properties, right? But when you are working with real time applications, when you will have hundreds of properties sometimes. And that too, those hundreds of properties mostly common for all microservices, like especially assume like email credentials, SMTP credentials, so everywhere email credentials are common, like similar to database point of view. Okay, similarly, you may have other credentials, so something like OAuth credentials, OAuth URL, security credentials. Okay, some kind of other config data, Kafka servers information, maybe some topic names, some values, whatever it is, some common values. These are all common to a lot of microservices. Then you can't define these are all things at every microservice level individually. Then every microservice, it just becoming like hell because you are making all these things at every microservice level. So that's the reason what you're doing. You are removing all this configuration data. See here now what I'm doing is I'll take first of all this information because this is the common information across all microservices, right? This is the common information. Why? Because DB credentials, service register URL. So now I'm taking this data, right? So now I deleted from payment service. If you observe here or not, I deleted from the payment service. And then let's go to the order service also. I'm deleting from here also. And deleting means now assume for the first time you are implementing the real web service, REST services, sorry, real microservices, then you are not added for the first time itself. So that means when you started your microservices application in real-time point of view, first what we will do, we will make our config server is up and running with all the configuration data generally. First we will implement this and then we will create microservices and we will give that URL. But right now what you are doing, just like we deleted all the data. See now I don't have user microservice. I don't have DB details. You know that without DB details, microservice will not start. Even payment microservice also, now you don't have the DB details. If you go to the order microservice also, now you don't have the DB details. So without the DB details, your microservices are going to start means 100% no. Even if you want to see here, let me start order microservice, let me start payment microservice, let me start user microservice. Nothing will start. All services will fail, like with the reason called as DB credentials are missing, service register is missing, something like that. See, DB details are missing like that. No microservice got started. But what we are doing right now is we are externalizing with the help of config server. So that means what you have to do guys right now, we have to understand implementation of config server first. Implementation of config server. Let's understand again. In this case also you have to understand a couple of other points. Okay, now concentrate with respect to this section. So later after that we will make our microservices as config clients. It's a very simple thing only, like how you made for Eureka clients. You added the starter, you added the annotation, right? Similarly, same kind of small steps you will do. But main agenda in this area is how to create config server application and how to configure this data in the config server application point of view. We have to understand. So now the concentration is completely on the config server creation, this area. And how you are keeping this data. This is all the thing we have to understand. Yes. So let's see here now. What the config server is, okay, Spring Cloud API. So this is all implemented by the Spring Cloud team, right? So what these guys are saying here it is, the moment you created config server application. So whenever we are trying to create the config server application, the moment while you are creating the config server, what we did right now, we understood this data, especially this kind of data, right? So this data we have to add in the config server, but how to add it? So you can't add directly in the config server level this data. So what in this case config server is designed here it is by Spring Cloud team. So this data you have to keep in the local file system. So that means whatever the configuration data we are trying to add, local files. So I'll tell you what is the meaning of local file system. As well as one more option they provided called as making your configuration data at GitHub level. So your GitHub repository level. So either of the option you have to choose based on your requirement point of view, and I'll tell you what is the real time point of view people will use, and one of them we will take. Or else you can keep the data in a table, database level, in a table level. So generally what is this configuration data means key value pairs data, right? So that means here config server application is going to have get the data, whatever the config data you can centralize in a local file system. What is the meaning of local file system is, for example, if I go to the D drive, assume I am creating in my computer itself, I created something like new folder, something like Amazon config data, like that in my local computer itself, because in my local computer only I'm creating the microservices, right? So in my computer itself, I'm running the microservices. So like that, in this local computer itself, in the local server itself, if you created like, okay, in this case, file names, you have to take same file names, guys. Okay, let's do one thing. New text document, application dot properties, and I will add all this data here itself. This data I will add in the application dot properties file level. So I added here. Now what I will do is I'll give this path while I'm creating the config server application. If I'm going with local file system approach, wherever I created D drive, Amazon config data like that, this file system path I'll configure in the config server application. This is first up, one of the approach. Okay, using local file system. So 99%, nobody will use this approach in real-time application. 99%, no one will use this approach in real-time application. Because the reason is, when you are deploying your applications on servers, the paths will change from one server to another server. There are a lot of challenges. File system, local file system, lot of challenges are there. It's the biggest challenge. So people will never ever use local file system. Why? Assume some reason this file got deleted or whatever it is. 99% there are a lot of drawbacks available with local file system, but still config server is providing support for local file system, but in real time no one will use it. Okay, cool. Then next approach, second approach, so using GitHub. So that means what it was trying to say is create a GitHub repository. Go to your GitHub accounts. GitHub means source code management, right? You know that. Overall, I'll explain you first, and then we'll go with anyway implementation also. Okay, let's do one thing. So I forgot my password. I'll do it. But anyway, let me explain you. You know what is a GitHub also, right? So what it was trying to say is, same, create a GitHub repository, and then in the GitHub level, keep your configuration data. So that means same file, whatever we are just planning this information, right? Application.properties file point of view, you will keep in the, for example, application.properties file you will create, and all the data, that configuration data, this data you will add. So that means the second, the config server is integrated with the GitHub account, GitHub repository. So here you will give it your GitHub details. You will give the, like earlier you given, I said if it is file system, here you will give the file path. But in this case, we are using GitHub, right? So you will provide GitHub information, like what is your URL and all, like that you will provide GitHub information. Now what will happen the moment we started config server application in the backend? See, in this case, config server application is getting data from the GitHub level. This data maintained at the GitHub level. And from there, config server is connecting, and then it is sharing all the information to all microservices. Now these are all microservices. I said like config lines. So user, order, see here, what's happening, order, payment, like that, all 40 microservices. What will happen, guys? Connected to the config server. Make a call to the config server. But internally, config server is also again in the backend. It is maintaining that respective configuration data, not directly into the web application. You are not maintaining directly into web application. In the backend, again, config server point of in the backend, it is maybe maintained in the local file system or GitHub account level, or you can create a DB table also. So they given some approaches, guys. Okay, 3 approaches they given mainly. So they given some documentation also. You have to create a table, database table, and that database information you will give here. That database information you will give here. That file, that table name, in which file the properties information is available, key value pairs, all this key value pairs, URL, all this data. So that is all you will configure inside a DB table level, and the DB table information you will configure in the config server. So that means this is how total 3 approaches they given. Spring Cloud config server is supporting total 3 approaches. We have to choose one of them. So which one is the best approach? So in my point of view, okay, not in my point of view. So most of the times people will go with, I saw in both the things, guys. So couple of applications are using second approach. Couple of applications are using third approach also. So that means, but it is very rare case. Local file system, nobody will use. But second approach, most of the times people will go with second approach. That means they will keep all configuration data in the GitHub repository. The biggest advantage of this approach is, yeah, this will be used people more, because in the GitHub repository level, you will have version history. Version history means what? What is the, when you change it from one value to another value, what will happen? I mean, the who changed that value, which user, which developer changed it, what is the old value, what is the latest value. You will have all this information. So here what you have to do, here you have to create a project, and then I will show you that step by step. So this is the best approach and people will follow. So what is the advantage of this one is, for example, I think I given earlier, I thought to previous batches. Yeah, this is one, December 6, 2023. See, like this, you will create a repository and here you will maintain all the information. See, like this. So the advantage of this one is you can see the history also, like what at what time the file is added, who changed, what is the previous change, what is the latest change. You can see all the information. See, password changed on which date. So this change is happened on December 6th. Okay, something like that. The old value is delete 123, new value is ABC 123. So that means in the source code repository point of view, you will have version history. That's why people will prefer this option mostly. And DB is also people will prefer, but this is the best option. So what I will do is I am also taking this approach only. So we will go config server creation. So in interviews, you have to explain, guys. So config server, when we are implementing the config server, okay, the configuration data we are not maintaining directly into config server web application. We are not maintaining. Again, config server is taking three, okay, help of either local file system, that means created in the so and so directories of that property files, and then giving that path information to the config server. That is one approach. Second approach is maintaining all properties information in a GitHub project level, and that GitHub configuration, GitHub information, that project information will give inside the config server. That is second approach. Third approach is you can create a DB table also, and in the DB table you will maintain all config data, application or properties, whatever the data you have, right? That data you will insert into DB table level, and that data you will give it. So total 3 approaches we will have: one, second, and third one approach. But out of 3, GitHub, okay, maintaining a version control system, nothing but GitHub level in a source code repository point of view is the best option. The reason is you will have version history, and you can control also which developer can access that project, which developer cannot access. In the real-time project point of view, you have a lot of control on this case, and you can see version history. Like see here, you can see all the history, who changed the file, at what time file got changed. You will have all the information after three years back also what happened. You can have all the version history. But in the DB level, maintaining this kind of version history is very difficult. So that's why people will prefer this option as a best option, because you will have always a trace. Now, if you go here, see, it's showing, right? December 6th, some changes are happened like that. And if you go here once again, all commits. So see here, lot of changes happen. Who changed at what time? August 3rd, August. See, 2 years back data also you can see that. So that is why these people will prefer. So what we will do is we will also go with same approach. So we will also create config server. We will also create config server with GitHub repository point of view. We'll go with second approach, and in interviews also you can tell them this is the best approach and explain them why this is the best approach also. So you will have like version history and everything, and you can have security point of view and which developers can access all these things. You can do that. Especially real time people will understand what I'm saying right now. So now what we will do, we will create config server application with the help of GitHub repository. So then that means this overall we are calling it as a config server. Once you are done with this setup, that means your config server is completed. So let's go with real-time point of view. Second approach only I'll take, and let's implement the config server, right? So you can take existing repository also, but you can create old repositories also. It's up to your choice. I'm new repository, or you can take old repository also. I think I already have for previous point of view, but it's okay. I'll create new one. Don't worry. Same thing you can follow. Okay, let's start implementing the config server. So you understood right now, in this case, what is the approach we taken is the backend. What we are taking in this case is GitHub repos. Okay, step number one, create config server application. So how to create config server application? So go back. See, as of now, I deleted from every microservice, guys. Okay, because we are going to centralize this DB details in a config server point of view. So what is the first step you have to do? Create a config server application, Spring Starter project, and go here, Amazon config server, something like that you can give, project name. Fine, next. So see here, Spring Cloud config. So what is you have to take this time is config server. See, this is the config line. That means all our 30, 40 microservices level, we will add this later. But right now we are creating server application. Central management for configuration via, see here, these guys also saying like go with Git is the best option, something like that. So we'll go with server application. So we are creating server. See here, I created what, guys? Server. And next, that's all. You don't need to do anything. Just you have to add this dependency, config server dependency or starter. We can call it as. So what is the starter you have to add? Config server and finish. So with this, what happened? Your config server application is about to, we are creating that. Yeah, if you go to the config server now, so this is the main application and this is the application.properties right now created. So now next step, with this config server is not ready. So in this case, what you have to do next step in this case is, maybe if you want to give your own port numbers and all, you can configure. So we can give port number, configure port and path. So what I'm doing is I'm just giving this application should run on the config server should run on the port number called as 8899, something like that I given, or you can give 9999, whatever it is. Okay, and I'm going to give context path also, servlet context path equal to slash. You can give something like config server or whatever it is. I'm giving like just like config or whatever it is. And then, so with this, okay. So it's just like instead of starting on the default port number 8080, we given our own port number and we given our own context path also. Okay, what we did right now is these are the second steps. And the third step, what you have to do here, it is common step, add an annotation called as @enable config server. So let's go here now. Here, @enable config server. So this is the third step you have to do on main method, on main class level. Main class level means you know that Spring Boot main class. With this basic Spring Boot application, config server got created. Let's try to start it and let's see what will happen. See what I'm doing. I'm starting the config server application. See, it's not going to start. Why? The reason is actually what is the purpose of config server? Maintaining some configuration data via local file system, either GitHub or database point of view. But right now what we did, we created only empty application. We are not at all provided either of these options, right? So that's why, see that error you will get now. See here what it is saying. Okay, Dilip, you created config server application. That's okay. But where is the source? From where I have to pick up the data? So whether you are maintaining local file system or GitHub database like that, it is asking. And it is by default. See, by default, these guys also supporting what, guys? Git only. So if you are using the Git profile, then these guys are saying like give the Git. If you are using local file system, give me local file system. If you are using database like that, it is asking that. If you have said you need to use a composite configuration. So invalid config server configuration, that's what we are still having couple of steps pending, right? So what we decided, we are going with second approach, GitHub level, right? So what I will do right now is let's go to the GitHub. See, please create your own GitHub accounts, guys, because it's a mandatory knowledge nowadays anyway for everyone. And let's create a repository now. So let me create a repository, new repository, and I'm giving something like Amazon config data. You can give any project name, I mean any repository name, config data, something like that I given. Okay, so make it as public, okay, for time being. Even you can give private also. But if you given private means you have to add some two extra properties, your username and password, but make it public first of all. Nothing will happen. You are not keeping much secrets, right? No, nothing will happen. Okay, I made it as a public and then I'm creating the repository. So public means without security, anyone can access. Even you can also see my code now, whatever I'm adding in this repository. Okay, so once you created this, what you have to do is you have to add a file called as application.properties. How to add, creating a new file. So so in this case, guys, you should have definitely some knowledge of GitHub, Git commits, push, pull, all this knowledge. So I am recommending you from day one onwards. So just go through it. Right now, you can do directly from here also. Create a new file. So here what I am doing is file name is, see here, you have to follow again the file names properly, guys. Whether you are going with YAML, define YAML format. If you are going with properties file, define properties file format. We discussed these things in the Spring Boot. Now the point here it is, what are the file names we have to take in this case? Yes. For common properties, understand the points. Now what we are doing, fourth step point of view, creating GitHub repository. So in this case, what we are doing is we created an application.properties file. Yes. So same properties file you have to take, guys. I'll tell you later. Continuation to this session, we will have one more session also it will take. So then I'll tell you how to add these properties files and what, I mean, apart from application.properties file, what kind of properties file we can add, any other specific properties file we can add or not, those details we'll discuss. Right now I created application.properties. Yes, Spring Boot always prefer application.properties. That's why you're also, we have to create always here also same thing, application.properties. Okay. So what I'm doing is I'm just taking this data and I'm adding here. I'm adding here. So commit changes, right? So now in the Amazon config data level, yes, you created application.properties and you kept all this information in this case. Okay, now what you have to do, go to the config server, open the application.properties, add respective properties in this file and okay, commit it. So what are the properties we taken? We thought like first we will take this 6 to 7 properties, right? So that's why I added this 6 to 7. Now what is the second next step you have to do is fifth step. Now configure GitHub repository in config server application. So that means simply you are integrating config server with GitHub point of view. Now configure GitHub repository info in config server application. So config server application is nothing but properties file, right? So let's come back here. What you have to do is it's all some predefined property. You have to provide this URL first. You have to provide this URL first. Okay, let's see here what you can do. See, that's why in industry, even I can see like 5 to 6 years, 7 years, 8 years, people also, so many people are not understanding. I mean, so many people doesn't have knowledge of microservices. The reason is it involves a lot of configuration rather than coding. Spring.cloud.config. Yeah, if you see here config server, AWS, even they are supporting a lot of other things also, guys. Not only this. That's what I'm telling you. In real time, you will see a lot of new things. So here we are just taking only basics. See, Google Cloud also they are supporting. They are supporting AWS also. That means you can keep this configuration data in the AWS point of view also. That is how it's not only this things. Config dot server dot git. Yeah, we have git now. So this is all related to git. So what is the git? You have to take clone on start equal to, you don't need it. Yeah, see, I told you, right? If you created private repository, then you have to give password and usernames, guys. Okay. But we created public only so that don't need it. Yeah, I think we have to take yeah, URL. See, this is username. In case if you are giving private repository you created, then you have to provide username and password as two extra properties. But right now we don't need it. So what is the URL you have to provide in this case is go here. So here code, copy this URL, code and HTTPS URL you can configure here like this. So it should be like this. This is the URL only this is the GitHub repository URL we created application.properties. And then next property, we have to say some, okay, let's start from this. What's happening? Let's try to see. So we given this GitHub URL, right? Let's see our Spring config server is getting started or not. What happened? Yes, it got started now. Now let's test the configuration information, nothing but the properties information getting loaded or accessible by the config server from this GitHub repository or not. So for that, what you have to do is, so let's prepare the URL. Yeah, localhost colon, and what is the port number we taken? 9999 / and we taken something context to path as config server, right? So if you see here, context to path config server is the context to path. And then slash, here generally you have to provide microservice names, nothing but config client names. Okay, right now we are not created any config clients, right? So even we can give anything else, nothing will happen, it will work. So now the second part what we are going to give here, it's all about profile name. So I'll explain this URL. I mean, I'll explain these things in the upcoming steps once we made our config lines are ready. So right now just run this URL. So that means until this context path and port number, and after that just microservice name and profile name. So what is the profile name? What are the profiles and all? We know, we understood in the Spring Boot profiles level. So what is the default profile? Also we understood. Okay, now let's take this URL and go back to browser and access. Yeah, so see here now. Now we are able to see all our configuration information from the application.properties file, which we added as part of this GitHub repository. We can see here. So that means what's happening, guys, in this case, the config server is able to make a proper communication with our GitHub repository. So that means now config server is pulling all the configuration information from the GitHub repository. Now after that, what we will do, we will make config clients, right? So the next steps is all about, we are going to make config clients. So whenever we made the config clients, we will give config server URL. So that means config server URL we given means internally config server again pulling data from the GitHub, like all this information what you are seeing, like DB credentials, whatever it is. Right? Now that data being loaded into, so whenever they are getting started, that all this config information getting loaded at runtime level, and our applications will start successfully, as well as all these values will be injected into our respective microservices or config client applications. Okay, so in the next steps, we will see that what is the how we are going to make config clients, and how we are going to provide config server information in the config clients, and what exactly the meaning of default. Okay, how we are going to access profile based configuration information, and what are the rules we have to follow with respect to config server point of view. And whenever we have common data across all microservices, what we have to do when you have specific to microservice config data, then what we have to do. So these are all use cases we will discuss in the next session. So that means until right now what we completed is creating the config server and integrating our config server via GitHub repository we are completed. So extended to this, we will discuss all the use cases and all the points related to our config clients point of view. In the next session, we will discuss each and everything. So far whatever we discussed, all this information again documented in my Spring Boot and microservices material. So here you can find out all the theory description about config server advantages. To answer as part of interview questions point of view, I included all the details, and you can see all the implementation steps, what are the annotations you have to add, what are the starters you have to add, and how to integrate. Okay, config server implementation with GitHub repository, what are the properties you have to take, including all architecture diagrams. All this information is documented in this material. If you want this material, you can visit courses.delipit.com, and from there you can purchase this one. So this document contains further sessions information also, like how we are making config clients and how we are going to integrate config clients with the config server, and what kind of information we are moving to the config server with respect to common of all microservices and specific to microservices point of view. So I documented all these things as part of here, and these are all things will be covered in the next session.